All right, so here we are. Implicit differentiation examples, more examples. Like I said the last time, you need to see these and do these a bunch, and then they start to click for you. Um, but we're going to start off looking at an AP problem. So we've got an equation. It's defined implicitly, and we want to show that. So this is an actual AP free response question, and it's nice because they give us the answer and they just say, and they say, show me that you can find that answer. So to do this, we take the derivative with respect to x of both sides. Okay, so right away, the right hand side, we can we know it's the derivative of a constant. The derivative of a constant is always 0. And now we're going to work left to right. But before I do that, let's just acknowledge that in the middle we've got negative 5x um, and y, and we're going to need to use the product rule. So I'm going to split that up as negative 5x being one function and y being the other function. So when we take the derivative of y to the fourth is 4y cubed times the derivative of y. And um, now let's go in. So derivative of negative 5x. So now we're doing this. Derivative of negative 5x is negative 5 times the function y, uh, and then minus 5x times the derivative of y. So this was the product rule right here. Um, if you need some reminders of the product rule, think of f as negative 5x. So f prime is negative 5. G was y, so g prime equals y prime. So my product rule is going to result in negative 5x times y prime plus negative 5 times y. So that's how I'd get I get this double green underlined result. And then we have the derivative of negative 7x, which is just minus 7. So bringing things over to the other side, working very slowly here, we get 4y cubed. I'm going to write just y prime to save space. Minus 5x y prime equals 5y plus 7. Factor out a y prime. And we get 4y cubed minus 5x. I'm going to switch the order on the right-hand side just to make it look like what I'm trying to make it look like. And then divide. And when we divide, I'm going to get dy dx equals 7 plus 5y over 4y cubed minus 5x. AP free response problem, part A, done. Then it says, write an equation for the line tangent to the curve at the following point. So we know the point is 2, 1. We need to find the slope. Well, to find the slope, we know that we're really talking about the derivative. So we want to find dy dx at those values of x and y. So we're just going to plug those in. 7 plus 5y, where y is 1, over 4 times y cubed, well, 1, minus 5 times 2 equals 12 over negative 6, which is negative 2. That's our slope. Now, notice this type of problem would be without a calculator, so you'd need to be able to do this sort of fractional work pretty quickly in your head without making a mistake. So take your time, learn how to do that well. Uh, just get in the habit of putting your calculator away and plugging in numbers by hand. You are a smart person. You can do that. Okay. Anyway, enough of the motivational speech. Tangent line. We have y equals m x minus x1 plus y1. The slope we just found is negative 2. Our x point is 2, and our y point is 1. There's an equation for my tangent line. Done. And then the last problem, find the second derivative. Well, the second derivative is the derivative of the derivative at this point. So to find the derivative of the derivative, I want to take the derivative of dy dx, which is the derivative of 7 plus 5y over 4y cubed minus 5x. Okay, well, this is going to get a little bit ugly, but it's um, using the quotient rule. So the derivative, uh, finding the derivative of this here, which is my second derivative, it's low, d high. Well, the derivative of the high function is 5 times dy dx minus, so minus high d low. Well, that's 12y squared times y prime minus 5. That's uh, that's the derivative of my low. And that 12 came from, this 12 came from dropping the 3, 4 times 3. And that's all over low squared. So 4y cubed minus 5x squared. Um, and the thing that we need to remember is we're finding the second derivative at the point 2, 1. And we know that at 2, 1, y prime at 2, 1, we already found that. That equals -2. So now we're just going to go and plug things in. We're looking at the point 2, 1. So y double prime equals 4 times equals 4 times 1 cubed minus 5 times 2. I'm going to run out of space, so I'm going to write a little bit smaller. The second derivative equals 4 times 1 cubed minus 5 times 2 times 5 times dy dx. Well, dy dx we know is -2 minus 7 plus 5y. So 5y is just 5 because y is 1 times 12y squared y prime. So that's 12 times -2 minus 5 all over 4 minus 5 times 2 squared. Well, what this is definitely an ugly fraction, but we can go ahead and simplify this no problem. Y double prime equals 4 minus 10 times -10 minus 12 times -29 all over -6 squared. Okay, well, this is getting a little bit ugly, but we keep going. We get, let's see, 60 plus 12 times 29. The negative and the negative goes away, over 36. And then we can further simplify that. Let's take a 12 out of the top. 12 times 5 plus 29 over 12 times 3. 12s go away, and we get 34 over 3, which is my second derivative at the point 2 comma 1. AP problem. Expect that sort of level of kind of just fundamental mathematics. They want to make sure that you can add and subtract and multiply, factor, divide. All right, back to sort of more textbook problems, a little bit quicker. It says find an equation of the tangent line at the given point. So at this point, so we know what to do. We take the derivative. And we're going to have to use both the chain rule and the product rule here. The right-hand side we know is 0. Derivative of a constant is 0. And on the left-hand side, the derivative of y becomes dy dx. And now let's go through this a little slowly. So the first function is, here's my first function, and then here's my second function. So derivative of the first is just 1 times the second plus the first times the derivative of the second. Well, the derivative of the second is negative sine of y times y prime. And that's all equaling 0. So kind of bad form here using two different expressions of the derivative, but they're the same thing. So let's factor out a y prime and as well as moving this to the other side, and we get dy dx times 1, let's see, minus x sine of y equals negative cos of y. So dy dx equals negative cos of y all over 1 minus x sine of y. And if we plug in those points, 5, 0, to find out the slope at this point, we have negative cos of 0 over 1 minus 5 times sine of 0. Knowing your trig tables, we know that that's negative 1 over 1, which is just negative 1. And to find the equation of the tangent line, well, this is my slope. Here's my point. So the equation line will be y equals slope times x minus x1 plus y1, or negative x plus 5. All right, so I'm gonna stop this video here and start up the next video where we will look at about 3 other problems. So um, make sure that you spend the time to watch these, follow these, try them out on your own. And in the next video, I would recommend that you, before I start doing the problem, maybe pause it once you see the question and try to get an answer on your own, and then see if it pairs up with what I got.